Good morning, learners. My name is Gishingiri Kamweli, a teacher of drawing and design at the Movie Forces Academy. Today, from tools, we are going to do geometrical construction and specifically polygons. 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 Polygons means many sides. By definition, a polygon is a plane figure bounded by 4 or more straight sides. The construction of polygon is very important in that it is useful in all forms of mechanical engineering. All bolts and nuts are constructed using the knowledge of polygons. The design of some houses in architecture and also all construction, building construction, will borrow at some point the knowledge of drawing polygons. Some of the polygons that we are going to study in this lesson include one, the pentagon. Having studied the square when we were doing quadrilaterals in Form 1, we are going to start at the pentagon. 2, we are going to study the hexagon. 3, we are going to start the heptagon. Then the octagon. We may also go to the nonagon, and just in case we have forgotten, then the decagon, which is the 10-sided figure. 10, this is 9, then this is 8, then this one is 7 sides, 6 sides, 5 sides. Since you've said that it's bounded by more than 4 sides, 4 or more sides, it means then that we can go all the way to infinity. But it serves our purpose to do this 6 or so polygons. And for just in case, out of curiosity, what will be the name of the 11-sided polygon? This one is a heptagon, and this one is 11 sides, and 8 is for the decagon, which is 12 sides. So on to construction, and we are going to start with the hexagon. We will start with the hexagon because it's the simplest to draw. When we are given the distance, we start with the hexagon. It's the simplest to draw. And then let's say that our side is 30 millimeters. Transpose that one to lower part so that we have millimeters. Millimeters. Usually, serves of purpose to note that in a hexagon, the radius of the circumscribing circle to the hexagon is equal to one side. So when you're given the sides, you can just get into the middle there by drawing an arc with the radius equal to one of the sides, and when you get that center, you join it there at A and B, and then proceed to draw this circumcircle. Our title is a little in the way. We are going to rewrite the title again. And you have that circle. So now when you are given the side, if you step it off 6 times along the circumference, you are going to find that it is exactly 6 sides. So when you're given the sides, proceed to complete the hexagon. The hexagon and the sides, this is O, the center, and this one is 30 millimeters, equal to one side. And we are saying that when you step it off around that circumference, you get step off the side around the circumference, you get the hexagon. So this also is called the distance across parts, across corners. And it's also referred to as the diagonal of the polygon. Across corners is abbreviated that way, and that's an internationally acceptable convention for that, across corners. And this one represents the diagonal of the polygon. On this other side, we will mark again that way, and if you look at the length here, this distance is referred to, that distance is referred to as across flats, and it's also called the diameter of the polygon. So this one is across flat, and this one is the diameter. The diameter of the polygon. So distance across corners is the diagonal, distance across flats is the diameter. Now, the hexagon can also be constructed as tangents to a circle, so that when you're given the diameter, as we said, this is the hexagon, and our third topic has been compromised by the size, so we write hexagon. Hexagon, method A, and in this case we said we are given one side, and we have been able to establish the diameter and also the diagonal. Now, when you are given the diameter, method B, where the diameter is known, again, hexagon, given diameter. So remember, we have seen that diameter is the distance across part, or it is the diameter really of an in circle. An in circle, as we learned earlier, is what is drawn inside and it touches all the sides of a quadrilateral or a polygon or even a triangle. So in this case, what we need to do is to draw lines which are tangential to either the horizontal diameter of the in circle and so when we get lines which are tangential to the circle, a tangent, as we said earlier, is a point that touches just a single part of the circle without cutting it. And if we get tangents at that increase to enjoin the two vertical lines which are perpendicular to the horizontal axis of the in circle, we can be able to complete the hexagon in this manner, so that we draw our points, our lines which are tangential to the circle that way, and also on this other side we do the same. Again, tangential to that point, to the circle. That will decrease. we are accurate, the 2 points lines should meet at the same point. So we check whether our lines are okay. If you find that there is a problem as to where they are going to meet, investigate which one of your lines is out of the center. So maybe our original line here is slightly out of line, and then we should draw it that way. If we get the tangents again also at an angle of 90 degrees above here, and on this side also at an angle of 30 degrees from a true vertical line, the two lines should actually meet at the same point, and that will be a method of drawing the hexagon when you are given the diameter of the polygon, which again we agreed that the diameter means the diameter also of an in circle. So you proceed to outline the completed hexagon. So once again, when we are given the diameter, bisect the diameter, draw the circle with half of the diameter being the radius, and proceed to draw tangents at an angle of 30 degrees below here, and also on the other side at vertical, completely vertical, and at 30 degrees at this one. So if this angle is 30 degrees on either side of the true vertical line, then we complete that hexagon. The next polygon that we construct is the octagon. The octagon. Learners, the octagon is an 8-sided polygon. An octagon. Octagon. So octagon, you can think about an octopus, which is an 8-legged creature. You can think of an octogenarian, who is 8 years and over. But this one is in construction. Now, to construct an octagon, a regular octagon given the diagonal, that is, when we are given the diagonal, again we say it is within a circle. Given the diagonal here is given to us as 8 millimeters. We say the diagonal is merely the distance across corners for a polygon. So diagonal is 8, therefore our radius is 40 millimeters. 40 millimeters. So the usual way when we are drawing the octagon is to bisect the angle. You can do that because we do know that each one of the external angles of an octagon is 45 degrees, which is 360 degrees divided by 8. So if we connect these lines across through the center, across the circle, that way, and join the vertices so formed, we are able to get the required octagon when we are given the diagonal, which is the distance across corners. So we proceed to join that and with an outline to complete the required octagon. So you are going to discover all the vertices are equal to the sides of polygons. So if this is number 1 for us, 2, 3, 4, 5, 6, 7, and 8 vertices, and also the sides are 1, 2, 3, 4, 5, 6, 7, and 8. So that is the required octagon, and we have said that for the diagonal distance for this diagonal is 8 millimeters. The next method that we aim be 70 millimeters. Let the square be 70 millimeters. All these assignments we do them by use of compass and the T-square, the set square, but not use of protractor to measure angles. So let's construct the squares. By now we should be expert at the construction of square, having done quadrilaterals. So our square is A, B, C, and D. Now, as usual, we get into the vertex A and construct a line which is perpendicular to point AB at vertex A, so that we erect a perpendicular at that point. So we do that by getting the two arcs and bisecting the difference. To complete or to get the one side of the square. So once again, get that length and then mark AB on the new perpendicular line at that point, and proceed to make two intersecting arcs from B and the point which we have gotten earlier, and we say D. So we have been able to use the same length to get arc or to get point vertex C. So we proceed to do that, construct the square. Remember that this is not the objective of the entire construction, so we don't outline that square, it is still construction work. Our purpose is, or our target is to construct an octagon within a given square. Octagon within a given square. Once again, octagon. And the square is 70. So having now constructed the square, draw the diagonals of the square and let them intersect at the center. We do know the properties of a square that the diagonals are equal and they meet at 90 degrees. So even by quick inspection, we can see that that is so. Now from vertex A, we have the diagonal. Draw an arc in that way, and then from B, follow the same. Draw that arc with the radius of the diagonal, and proceed to do the same at C and D. That's okay. Then at also D, we have the diagonal. Yeah. Then we can use a different color for this one so that we can see what it is that we're getting in order to trace the required octagon. That point. You'll be very keen as to the arc that you are seeking to enjoy. And that is our required octagon. That's the required octagon. So with vertex again, you can start counting 1, 2, 3, 4, 5, 6, 7, and 8. And the sides are also 8. Octagon within a given square. So the pentagon. The pentagon is a 5-sided figure. The pentagon is a 5-sided figure. Five-sided polygon. And it is a very unique construction for the pentagon. It uses one method which was advanced by a Greek mathematician called Euclid. So there is the Euclid method and also the universal methods for drawing polygons, where we use in construction of the pentagon. Now, let's use the first method. We are given a side of the pentagon, AB, and the AB, the length of that pentagon is 30 millimeters. Let's use a huge one. Let's use 40 millimeters. 40 millimeters. The key, what we are required to do is bisect that 40 millimeters. And we bisect 40 millimeters. You are required to trace on a point C here, which is half the length of AB. Draw an arc and also draw a perpendicular line from B. This one is perpendicular, erecting the perpendicular, just the way we are doing it. I've just discontinued the arc for gravity so that we can be able to locate the points. Lest there are too many. So erect a perpendicular at B. Now with AC, with the C, let's look at the point of intersection between the semicircle and the perpendicular line at D. We draw a point E, and we are going to find that AE is equal to the diagonal of the polygon. So if you get AE and draw that arc from the diagonal, where that arc touches that point, that is point F, which is the second line of the polygon or the pentagon. So that one. Okay. Now along the same diagonal, and the wing sides AB equal to BF, that way. Along the diagonal, the third point, that's EF, we can call that point maybe G, so that we have G. So that when we join points FG, we have the third line, the third side of the pentagon. If you get AB again, and on the other side you mark a second semicircle, and then using the same side from G, you can mark on that semicircle the 5 line, and you can see that they are joining, and you complete our pentagon by using this spectrum method, which was advanced by Greek mathematician Euclid. So he's given the credit for having advanced it, so that we have A, B, C, A, B, F, and G, and then we can have the point H, which is the required pentagon. And learners, today we've been able to go through constructions of polygons. These are part of the plane geometry, which involves other figures requiring the geometrical construction like Form 2. We have learned about how to construct a hexagon and a given diameter. We have looked at the octagon, and we have also been able to look at the octagon on various methods, and finally we have introduced the pentagon using that very special method called the Euclid method. So learners, until next time, goodbye.